Hi, so this topic is based on electricity, but I'll show you how and why you should be able to get 8 out of the 11 marks even without covering the topic electricity. So just using your mathematical skills and your critical thinking skills, you should be able to obtain at least 8 out of the 11 marks. So the first part says the student is investigating a resistance wire. She uses the circuit shown in figure 2.1. Then first part of A says on figure 2.1, draw a voltmeter connected to measure the potential difference PD in volts across terminals P and Q. So this first part, if you haven't covered electricity, yes, this could be difficult because you need to have covered and actually seen what the voltmeter symbol is, how you should be connecting your voltmeter. So it should be in parallel, and the symbol is V in a circle. So that first part, maybe you might not be able to answer that one, so that's the one of the 3 marks that you wouldn't be able to obtain. But this second question says the student connects the crocodile clip to a length L equal to 90 centimeters of the resistance wire and measures the potential difference V across the terminals P and Q and the current I in the circuit. Read and record in table 2.1 the values of V and I shown on the meters in figure 2.2 and figure 2.3. So now these 2 marks you should be able to get because you're not just reading off the values shown in the diagram. So in figure 2.2 we can see that our meter reading is 2.6 volts. So we go to our table and we can record here. So we've got 2.6 volts, and then let's look at our ammeter there, and we can see that the reading is 0.36 amps. So come back here and record our reading as 0.36 amps. So now we've got our 2 readings, and those give us this first 2 marks. And then going on to part B, it says the student then connects the crocodile clip to lengths L equal to 60 centimeters and L equal to 40 centimeters of the resistance wire. She measures the potential difference V across the terminals P and Q and the current I in the circuit. Her readings are shown in table 2.1. Then it says complete the column headings in table 2.1. So we know that the voltage is in volts, then the current is in amps. Then C part 1 says calculate and record in table 2.1 the resistance R of each length L of the wire. Use the readings from the table and the equation R is equal to V over I. So we've actually been given the formula, so we are simply now substituting our values from the table to get the readings. So for the first reading there, that would be 2.6 divided by 0.36. So that gives us 7.2. And then the next one is 2.5 divided by 0.49. That gives us 5.10. And the next one would be 2.3 divided by 0.74. That gives us 3.12. And then the next question says, calculate and record in table 2.1 the value of R over L for each length L of the wire. So simply dividing the value for resistance, which we got in the previous calculation, by the length of the wire. So that's 7.22 divided by 90. That gives us 0.080. So please note that for your physics papers, the minimum significant figures you should have on your answers is 2. So you should have a minimum of 2 significant figures in your answers. So then the next one is 5.1 divided by 60. So that gives us 0.085. And the next one is 3.12 divided by 40. And that gives us 0.078. Then the next part says another student suggests that the values of R over L for each length of wire should be the same. State whether the results support this suggestion. Justify your statement with reference to values from the results. So for this part of the question, there is actually neither a correct or wrong statement in terms like you could say yes, they support, you could say no, they don't support, as long as you give a reasonable justification. So if we were to say, for example, yes, the statement is supported, given that 2 of the values, which is value number 1 and number 3, round off to 0.08, and then only one of the values seems to be somewhat different from the other 2, and this can be justified or explained in terms of experimental accuracy. So it could be a result, of error. So these values could be considered more or less to fall within the same range. So that's how we could justify that answer. Then part E says, suggest one difficulty which explains why different students doing the experiment carefully with the same equipment may not obtain identical results. So to answer this part of the question now, we just need to use our critical thinking skills. So if we go back to the experiment, we can think of possibilities in terms of where errors might arise. So if we look at part 2, it says the student connects the crocodile clip to a length L of the resistance wire and measures the potential difference V across the terminals P and Q. So if we look carefully at our diagram, this is where our resistance wire is, and then the student puts the crocodile clip and measures the length. So there could be an error in measuring this length because it might be hard to judge exactly where the crocodile clip is. So it means we have some room for error in terms of where we put our crocodile clip. So that is one possible and straightforward explanation in why we may not obtain identical results. And then part F is also the one I was saying you might not be able to answer because you haven't actually covered electricity. But as you can see, we've been able to answer questions with 8 marks out of the 11. So let me know if you have any questions